Practices worksheet. That is the first worksheet from the page 3 notes. So the first question here is, like question number 1 here, the first 4, are determine if AB is tangent to the circle. So this would mean that AB, this line right here, right, is forming a right angle with the radius, which they just given us here. Let's pick a different color for that. Let's go with red. Now please bear in mind, this is a radius, right? So the idea is this making a right triangle? So if you look carefully, you can see a right triangle. And they give you some information. So they tell you that the radius is 12. How do you know? Remember, anytime you have a number from point to point, that means that is 12. The reason I made both of these red is because if this is 12, guess what this is? Well, it's a radius. It's got to be the same. It's also 12. So what this means is if you look carefully, we've got a right triangle where the hypotenuse is 20. So then simply put, we figure out if, because we know all 3 sides, it may seem silly, but the Pythagorean theorem can be used to verify that you're looking at a right triangle. That is to check. So it turns out that if you take 12 squared plus 16 squared, you're going to get 400. Remember, you have to square them and then add them. And if you take 20 squared, you're going to get 400. So what does it mean? This fits the Pythagorean theorem, so yes, it is a tangent. So the key thing is you try to figure out all 3 side lengths and then see if it fits the Pythagorean theorem. Remember, leg squared plus leg squared has got to equal hypotenuse squared. Another example, find the segment length indicated, and this is kind of key. Assume that lines that appear to be tangent are actually tangent. Why is that important? Because, as in the last example, we had to make some assumptions there, right? This appears to be tangent. If you look at it, it looks like it hits at one point, doesn't it? That means this has got to be a radius. How do I know? Because it's hitting at one point and it's going to the center of the circle. So that means what? Right triangle. Okay. Now, if you look carefully, the radius is 1.5 and this is 1, which means this whole side length, which happens to be, the hypotenuse is 2.5. Here's our question mark, what we're trying to figure out. What is this length? Wait, that's a radius. What that means is it is also 1.5. So we happen to know that question mark, which is a leg squared plus 1.5 squared, has got to equal 2.5 squared. Now, off the top of my head, I don't know what these are. I believe this is 2.25. I believe this is actually 6.25, so maybe I lied. But in any event, what this means is we could now subtract 2.25 from both sides and we get 4. And I happen to know that the square root of 4 is 2. So what did we do? We know that things that appear to be tangent are, and don't forget, radii are congruent to themselves. That is, if this is 1.5 here, that means this is 1.5 also. And now we've got enough information about this triangle, this right triangle, to use the Pythagorean theorem. Find the perimeter of each polygon. Assume the lines appear to be tangent are actually tangent. So please bear in mind, this measure of 10.5 is talking about this length here versus this measure here is 11.2. Now, I would argue we're close. Now, if this is 11.2, this is a point that's external, and these are a common tangent, which means that this is congruent to this, which means that that piece is also 11.2. Why is that helpful? Well, if this piece is 11.2 and the whole thing is 23.2, if you subtract them, it turns out that this is what? 12. That means that this length right here, let's go with green, we've already used red, this length right here has got to be 12, because 12 plus 11.2 is 23.2. But that means that this length has got to be 12 also. Wait, and you probably see it. Here's yet another common tangent from a common point, which means that this is 10.5, this is 10.5. So what does this mean? They want you to find the perimeter. So we're not done yet. That just means we need to take all these numbers and add them up. So the perimeter would be 10.5 plus 12 plus, well, I'm just going to use this whole 23.2 because they already gave us that, right? Plus the 11.2 and the 10.5, 11.2 and the 10.5, and that should get us all the way around. What does that mean? Well, in the end, if you add it all up, we get a perimeter of a nice round, drum roll, 67.4, and that's it. Another example, find the perimeter, but this time we're looking at a quadrilateral. There are a couple different ways to go here. So, thing one, we know that this length here and this length here have to be the same. Once again, common tangents from a common point, which makes this 4.6. Are we okay with that? Good, I'm glad we are. Now this is where it gets a little tricky. If you remember way back from when, we know that if we add the opposite sides, that is this side and this whole side length, right, then that's going to be the same as this whole side length plus this. Come back. There you go. So what that means is we know that 13 plus 4.6, 13 plus 4.6 plus 21.8 has got to equal, well, the 25 plus, well, the 4.6 we know, but what we don't know is good old x here, we'll call it, plus x. Remember, the sum of the opposite sides of a circumscribed quadrilateral, which is what this is because we have these points of tangency, have to be equal to each other. Now, when the dust settles, you can figure out what x is by, well, figure out what this is, all added up, right? Figure out what these two are, and you subtract them. And then you can simply figure out what x is. And if you do that, you end up with 13 plus 4.6 plus 21.8 minus the 25 minus the 4.6 means x has got to be 9.8. So x is equal to 9.8. And then, if x is equal to 9.8, and you add all these side lengths up, these two plus this plus this plus these two, you'll get the perimeter, which is what we're being asked for, right? Reading the question is kind of important. The perimeter equal to 78.8. So on this next one, find the angle measure indicated, assume that lines appear to be tangent or actually tangent. So please bear in mind that this and this are a radius. So if I'm looking at these two being a radius, that means they're congruent, which means this is an isosceles triangle. So if I look at this triangle right here, formed by these lines, that chord there and those two radii, that means if this is 63, this has got to be 63. Which means if these two are 63, I could take 180 minus 63 minus 63, which works out to be 54 degrees, and that means that the angle over here is 54. Big deal, you say. Why do we care? Well, here's why. We want to figure out this angle here. We know if this is a tangent line right here, we know that that's a right angle. Now, there are other ways to do this, but this is one way that it certainly works. We know that's a right angle. So we know that this is 54, this is a right angle, which means that question mark is equal to 90, because we already have 90 taken up, minus the 54, which equals 36 degrees. Key thing, don't forget, if you got two radii and you have a chord that connects them, you get an isosceles triangle. Similar, if you're looking at this, we can assume that these lines that are tangent appear to be tangent, and so that means we know that this is equal to this. And we know that, of course, this is equal to this, and this is equal to this. Now, looking at this carefully, I see a kite. But even if you don't see that, at the very least, I see a quadrilateral. I know that all these angles, question mark, plus 117, plus 90 plus 90 have to add up to 360. Which means when I take 360 and subtract all the other three angles, I should get 63 degrees, which is what the angle in question is, right there. So, similar logic. We've got a couple of right triangles, so I'm going to go with this kind of larger green one, right? I got one right triangle, I should say. A larger green one here. Just like that. How do I know it's a right triangle? Anything that appears to be tangent is, so that's 90. If that's 52, that makes that angle equal to, well, 90 minus 52, or what is that? 38? No. Well, let's just double check that. So what I'm going to do is take 90 minus 52, which is 40, which is 38 degrees. So that means that this angle here is 38 degrees. Now, if you look at again, you'll see another triangle. It's not a right triangle, but another triangle. This triangle, however, is isosceles because that's a radius and that's a radius, which means that is also 38 degrees, which means that 180 minus 38 should equal our angle, which is, well, that's 180 minus 60, 76, 104 degrees, which is what that angle equals. So we have two